Okay, guys, I think this is where we left off our last video. Y equals cosine x, and I sort of got cut off, so I wanted to come back to this spot. All right, so here's y equals cosine x, and you'll notice it looks very similar to sine. If I would start here and pretend like this is 0, 0, it would be sine. It's just shifted over. We start at 0, 1, and then we still kind of toggle through 1, 0, negative 1, 0, 1, 0, negative 1, 0. We just started at a different spot. Okay, so notice same domain, all real numbers. The x-intercepts are different. They're at the odd pi over 2s. That's where you're going to cross the x-axis. The period is still 2 pi. It takes 2 pi to complete one cycle. Okay, you're starting at 1, 0, negative 1, 0, 1. Kind of, cosine a lot of times looks almost like a U. No, it's just because it starts at 1, if you just look at the one cycle of it. And then, now, unlike sine, cosine is an even function. It's symmetric to the y-axis. Notice if I would fold this right on the y-axis, it would be exactly the same on either side. So with cosine, whatever the cosine of pi over 2 is, that's the same as the cosine of negative pi over 2. Whatever the cosine of 2 pi is the same as what the cosine of negative 2 pi is. With sine, remember, it was opposites. Okay, but with cosine, they're exactly the same. So if somebody says, what's the cosine of negative 3 pi over 8? You just have to figure out what the cosine of positive 3 pi over 8 is. It's the exact same thing. I think a cosine is like x squared. You know, but positive and negative, you're going to get the same y coordinate out. Okay. Amplitude is 1. Remember, that's the distance from the horizontal. That's the biggest y, the furthest y coordinate is from the horizontal. So the amplitude is the same as sine as well. All right, so now what we're going to do, guys, is graph translations, just like we did with polynomials, absolute value equations, square root equations, quadratics, every type of function that we've dealt with. What else do we do? Exponentials and logs, all that. I'm thinking back to college algebra. We did all those, and we noticed that, if we add something to it, it shifts it up or down. If we multiply by a negative, that reflects it across x. All that kind of stuff is the same with trig functions. Okay, it's just a little bit more tedious because of the cyclical nature of the graphs. So I'm going to show you a process and then let you practice. Okay, I'm going to show you a process with cosine and with sine, and then we're just going to have to practice these, and I'll show you the practice things that I have on Schoology for you. Okay? So with cosine, we have to think back. Let's go back to cosine, okay? We call these the key points. They're basically the quadrantal angles. 0, pi over 2, pi, 3 pi over 2, and 2 pi. That's what I wish I was taking the cosine of, because what the answers are will lead me to this one period through, right? It leads me to the entire cycle of cosine. So 0 gives me 1, pi over 2, 0, pi, negative 1, 3 pi over 2, 0, and 2 pi, 1. So I wish that's what I was taking the cosine of. So we don't have to wish it. We can make our wish come true, kind of. Okay, and we can take this stuff that we're taking the cosine of. By the way, I'm not showing my face because, as you can see, this grid takes over the whole thing, and I didn't want to. I did it before, and I was like drawing over my face, and that just hurts my feelings, kind of. So here's my 3x plus pi. That's what I wish was. I'm going to put over here what I wish. I wish I was taking the cosine of 0. I wish I was taking the cosine of pi over 2, pi, 3 pi over 2. We'll get so tired of writing these things over and over. Those of you that have pre-calc, it's probably coming back to you, huh? 0 pi over 2, pi, 3 pi over 2, and 2 pi. That's what I wish I was taking the cosine of, but I'm not. I'm taking the cosine of 3x plus pi. So what I'm going to do is make 3x plus pi equals 0. and I'm going to make 3x plus pi equal pi over 2. And 3x plus pi equal pi. All right, I'm going to make what I'm taking the cosine of. Notice I'm not dealing with this right now, just what I'm taking the cosine of. And I'm letting it equal each of these radian measures that I know make up my key points. Okay? And I want to know what x value will make 3x plus pi equal 0. So then I have to do a little algebra here. I have to subtract pi. That gives me negative pi. And then divide by 3, right? So negative pi over 3 is going to be my first x coordinate, okay? Same thing here. I'm going to subtract pi from pi over 2. Now, guys, don't do that on your calculator with the pi's in there because it's going to, you're going to get a weird, irrational number, okay? So I'm taking half pi and I'm subtracting 1 pi, right? So just think of it as like a half minus 1, which is negative a half. So that gives me negative pi over 2, and then I'm taking negative pi over 2 and dividing that by 3, which is the same as multiplying by a third. So I end up getting negative pi over 6. Here I'm going to subtract pi. Well, this is a nice one. Pi minus pi is 0. 0 divided by 3 is still 0. I'm going to subtract pi from 3 pi over 2. That means I'm subtracting 1 pi from 1½ pi. Well, 1½ minus 1 is a half. So that's pi over 2, right? A half pi is pi over 2. And then I'm dividing that by 3, or in other words, multiplying it by a third. That gives me pi over 6. Now I'm going to take 2 pi minus pi. Well, that's just pi, and then divide by 3. I get pi over 3. Now, some people don't do it this way with, sticking 3x plus pi equal to the 5 key points. They might do that a couple times, and then once they see what they're adding each time, like the difference between negative pi over 3 and negative pi over 6, if you can, you're increasing by pi over 6 each time, okay? From negative pi over 6 to 0, the difference there is pi over 6. From 0 to pi over 6, the difference is pi over 6. Like, you're always getting a difference of pi over 6 there, okay? Sometimes people just, after the first couple, they're like, oh, okay, I'm just going to keep adding pi over 6. Either way. Okay, y coordinates. They're a little bit easier. The y coordinates, I know what they usually are. Let's look back at cosine. They're usually 1, 0, -1, 0, 1. So I'm going to write that down. The y coordinates are usually 1, 0, -1, 0, and 1. Okay, when these were the x's. Okay, so what I'm doing to the cosine, after I take the cosine of this, okay, then I'm multiplying it by 2. That's what gives me my y coordinate. Okay, so I'm going to take each of these and each of what it used to be and multiply by 2. 1 times 2 is 2. 0 times 2 is 0. -1 times 2 is -2. 0 times 2 is 0. 1 times 2 is 2. And now I have my key points. I'm going to erase this mess so I can graph it. Okay. Is everybody all right? I hope so. I can't see you. Okay, so I'm looking down here, and unfortunately, these are by pi over 4s, right? This is negative pi over 4, negative pi over 2, negative 3/4 pi, negative pi. They're by fourths. So I have to think to myself where, estimate a little bit. Negative pi over 3 is between pi over 4 and negative pi over 2. So I'm just going to have it halfway between. Negative pi over 3 gives me 2. I'm going to have this be 1 and this be 2. Okay. And here we'll go with -1 and -2. All right, so what was it? Negative pi over 3 was 2. Negative pi over 6 was 0. 0 gave me -2. Pi over 6, I was back to 0. And pi over 3, I was back to 2. So my u is quite skinnier, isn't it? See that? My goodness, really skinny. To keep up with it, is a little tough, you know, because you're going by pi over 6s here. So you just want to make sure. I'm not doing that very well. Let's look at it on Desmos a second. Okay, and that's the other thing. I have no problem doing that. I love if you go to Desmos and try it. Okay, so Desmos, let's graph it on here. What was it? Y equals 2 cosine of 3x plus pi. 3x plus, go to my keyboard here and find my pi. There we go. 3x plus pi. And I would like to go to my wrench here and change my x's to, please, -2 pi to pi. I mean to 2 pi. And let's go by pi over 2's. My step is going to be by pi over 2. Okay. There we go. All right, so this shows you a little bit. Look where I started. Negative pi over 3, 2. Negative pi over 6, 0. 0, -2. Pi over 6, 0. Pi over 3, 2. You see it? Now, what's the period? How long did it take me to do a u this time? It took me from negative pi over 3 to positive pi over 3. So what was that period? It's like negative pi over 3 to pi over 3. And then here's pi over 2, 0, 2 pi over 3, -2. Okay, let's go back to our, wouldn't you say the period is 2 pi over 3? Right, it took me a pi over 3 to get to here, and then another pi over 3 to get to there, right? 2 pi over 3 would be the period. Okay, so if we go back, yeah, that looked a lot nicer, didn't it? Let me go to the next page here. To graph any sine or cosine function, that's why I have C plus. We didn't have anything added this time, but some number times either the sine or the cosine, I don't care which, of b times x minus d, where b is greater than or equal to 0. Okay, then this is what happens. The amplitude is the absolute value of a. The period is 2 pi over b. So remember, my b was a 3, right? It was 3x plus pi. So 2 pi over 3 is the period, and that's what we saw. I set this to the 5 key coordinates to find the new x coordinates. And then I find the new y coordinates by taking a, I took the a times it. You can use you have to find the x and the y coordinates. The phase shift is something they sometimes ask about. Phase shift. Okay, the phase shift is going to be, okay, if I have, this is a little different. If I have bx minus d, that I'm taking the sine or the cosine of, then the phase shift is d over b. If, however, the b is factored out, like here, then the phase shift is just d. Most times it will be like this, like it was in my example. Okay, come back for part 3 and we'll do a sine one. Okay.